So Stuart, you are on the cutting edge of quantum physics and consciousness and the intersection of those two.
Yes, Greg, I think quantum physics is the key to consciousness. You know, going back to the Greeks, there's been this controversy between whether the brain produces consciousness or some part of consciousness is out in the universe that we access. And quantum physics allows us to sort of bridge that gap and actually favors being able to access parts of consciousness or the essential features of consciousness which are present in the universe by working through the brain.
Are you saying that we are accessing something that pre-exists and we're basically just a conduit for it then, or do we have a say?
Well, it's not quite that simple. There are basically two approaches to the so-called hard problem of consciousness, namely the hard problem being why we have experience, why we have flavors, tastes, emotions, feelings, how we're different from robots or zombies, why we have an inner life. And the two approaches are basically emergence and some kind of fundamental approach. Emergence is the idea that conscious experience emerges at sort of a high level of complexity. The brain, like many other systems, being sort of a hierarchy, and if you get complex enough up that hierarchy, voila, some new property emerges, like a storm, for example, a hurricane or a tornado is a pattern that emerges from simple elements, gas molecules, air molecules, working together to make a funnel cloud, for example, or the great red spot of Jupiter, or a candle flame is an emergent property, or the property of wetness from water is an emergent property. So many people think that consciousness emerges as a new novel property at a high level of complexity in this hierarchical system that we call the brain. The problem with that, I think, is that none of these other emergent phenomena are conscious. They don't have conscious experience. Moreover, there's no real prediction at what level of complexity consciousness might occur in the brain. And if that were the case, computers should be conscious already or should soon be. So for that reason, plus the fact that that would take away any possibility of free will, it also wouldn't give us this property of binding, how we bind everything together into one sense of self or unity of consciousness, and how we transition from the preconscious or subconscious to consciousness itself. These problems, I think, suggest that there's something more to consciousness than being an emergent property of computation. The brain is more than a simple classical computer.
When you say that computers would be conscious by now or soon, does that mean that they're doing as many computations as our brain is doing right now?
Well,
or will be soon?
Well, they will be within the next 20 years or so. And people make these predictions that when the brain reaches a certain level of computations equivalent to the brain, it should be conscious. But of course, then they'll hedge and say, well, no, it's not organized the same. They'll keep pushing the boundary back. But the first problem with that is that AI people, artificial intelligence people who make these predictions, assume that the brain works along the lines of a computer, in that the neurons of the brain and their connections, the synapses, are the fundamental units. So, for example, we have roughly 10 billion neurons, with 1,000 connections each, or 10,000 switches to other neurons, which gives us about 10 to the 15th operations per second, with each neuron operating as a fundamental unit. The problem with that is that each neuron is much, much more complex than a simple switch. For example, consider a single cell like a paramecium, a single cell organism. It swims around, it finds food, it learns. If you suck it into a capillary tube, it escapes. And if you do it again, it gets out quicker and quicker each time, so it can learn, it can find mates, it has a sex life, it does all kinds of things. It doesn't have any synapses whatsoever. It's just one cell.
And yet it's conscious.
I'm not sure it's conscious or not. That's a little bit, but it's certainly intelligent, and it does complex things without any synapses. So if a paramecium, one cell, can do all those things, why should we think that a neuron is just a simple on-off switch, or that a synapse is just a simple on-off switch? The capacity of a neuron is much greater than that. If we go back to the paramecium, how does it do that? It uses its internal structure, its cytoskeleton, what seems like the structural support, but which is also the nervous system within each cell, the cytoskeleton comprised of microtubules mainly, which are these hollow cylindrical polymers that are seemingly perfectly designed to be information processing devices at the molecular level, a scale below that of neurons. They are the nervous system within each cell, the nervous system within each neuron, if you will. So these proteins, they're made of proteins, switch much faster than neurons. There's many, many more of them. Well, there's like 10 10 million within each cell, for example, switching in the nanosecond. So if we think of processing going down to that level, there's as much processing in one neuron at that level as there is in the whole brain, according to these AI-type estimates. So if we think that information processing in the brain goes down to the level of the microtubules, for example, we've increased the information capacity from 10 to the 15th roughly to 10 to the 27th. So that pushes the goal way farther for the AI people. The problem is that even if that were the case, even if we're doing 10 to the 27th operations per second, even if the microtubules are the fundamental computers of consciousness, that still doesn't tell us why we have experience, why we have an inner life, why we have emotions, feeling, what philosophers call qualia. That's just more reductionism, more computation, but doesn't solve the problem, nor does it solve the other problems like binding, transition from preconscious processing to consciousness, the problem of free will, and so forth. And actually, I worked on the idea that microtubules inside neurons and other cells were information processors, and for almost 20 years, suggesting that to understand consciousness, to understand the brain, we needed to go inside each neuron to this level to consider all this information processing. And yet, people would say, okay, maybe you're right, so what? How does that solve the hard problem, as it's now known, of consciousness? How do you explain conscious experience from just further reductionism? And I had to admit that they were right. Even if the capacity of the brain were squared, it still didn't tell us why we had consciousness. Because the same arguments against emergence that I mentioned before still held. So at that point, about 1990, I read a book by Roger Penrose, the Oxford mathematical physicist, called The Emperor's New Mind. And The Emperor's New Mind was kind of a challenge to artificial intelligence, AI being kind of the computer industrial complex pushing the idea that larger and larger computers will attain consciousness. And Roger's book was based on the idea that that our minds, our conscious minds, do something that is beyond the realm of regular computation. He called it non-computable. And basically it was the idea that we do things that we know things other than through algorithms, other than through things that a computer can do. And it's through Gödel's theorem, and it's mathematical and philosophical. And to be honest, I didn't really understand all those arguments. But my gut level was that he was right. He argued that to explain consciousness, to explain how we can have this non-computability, which is really another word for free will, or along the lines of free will, or going in the direction of free will. Because if the brain is just a computer, everything is deterministic. We're just reacting to things in our environment.
Which means we should be completely predictable.
Completely
in the same way a
predictable.
computer is.
Correct. Maybe with some randomness, but certainly no free will. And we would be, as the philosopher Huxley said, merely helpless spectators. We would be epiphenomena, just along for the ride. We wouldn't be in control of anything. We would just be, epiphenomena, just going along with our actions and observing, basically, without really having a say in what was going on. We might think we did, but it was an illusion. So Roger's idea was that the only thing in nature that can give us this non-computable element was a quantum mechanism, specifically a quantum gravity mechanism. And this seems so tangential to the idea of what's going on in the brain that most people really couldn't buy it. And it's a difficult concept, but to me, intuitively, there was something to it. Because what he said was, he likened the brain to a quantum computer. And that brings us into the world of quantum theory, which is a very difficult subject. In fact, Richard Feynman once said that anyone who claims to understand quantum theory is either lying or crazy, because it's so bizarre. For example, if you go down to the quantum realm, like small, like down, say, to the level of atoms, and it may be larger, but let's just talk about atoms, subatomic particles, things are completely different than they are in our classical world where things are firm and real and in one place, because at the quantum level, things can be in multiple places at the same time. Particles can be smeared out and act like waves. Things can be interconnected even over great distances. Time is smeared out. Everything is kind of different at that level.